Hello. Good afternoon.
Good afternoon.
Hello, how are you?
I'm fine, thank you. And yourself?
I'm also good, thank you. And we're happy to have you online with us.
It's my pleasure.
Okay. Just let me take 2 minutes to just give an introduction about this particular talk series, madam. Okay. So I welcome all of you to the 35th Transtech Technical Talk Series. It is organized by National Transportation Planning and Research Center, which is an R&D institute under Kerala State Council for Science, Technology and Environment. And today we are very happy to have Dr. Marianne Vanderschuren. I hope I have pronounced your name correctly. She is actually professor in Center for Transport Studies, Department of Civil Engineering, University of Cape Town. And it is with great pleasure and enthusiasm that I stand before you today and to extend a warm welcome to our distinguished speaker who has graciously accepted our invitation, and she'll be sharing her insights and knowledge in the realm of assessing road safety through different lenses, from raids to deserts. So it's a very interesting title itself. So we are eagerly waiting to hear from you, madam. And just for your information, so NATPAC has launched this Transtech Talk on 10th February 2023 through online platform. And the first talk in the series was delivered by Dr. Srinivas S. Puligurutha, who is a professor and research director of the Department of Civil and Environmental Engineering at the University of North Carolina. And the talk series was then carried forward by many eminent faculties and experts like Dr. Rajiv B. Malik, Professor R. Jayakrishnan, Engineer Tony Matthew, Dr. Sunanda Disanaike, Professor Sabya Mishra, and so on. So once again, I welcome you, madam, and please go ahead. And we are eagerly waiting to hear your talk on this very important topic. Over to you, madam.
Thank you so much. Thank you for the introduction, and thank you for having me for your 31st talk today. As you indicated, my name is Marianne Vanderschuren, and I'm talking about assessing road safety through different lenses. Before I go into the detail, the content, I will give a little bit of a background. Then I will talk about the safe systems approach, assessing road safety statistics through different lenses. And then I will take it a little bit into practice and getting to some conclusions. So the background, and given that I work in South Africa and Africa, most of my data will be related to that. But I start off with giving World Health Organization data, the latest road safety data that we have from the organization, published in 2023. The data is from around 2021. And India falls within the Southeast Asian region. And you can see that in the Indian context, 2- and 3-wheelers have the highest fatality rates per 100,000, almost 50%, where you see that 4-wheelers and pedestrians and cyclists definitely have less fatalities. If we compare that with South Africa and the African region, we see that 4-wheelers is 21%, 2- and 3-wheelers 18%, bicycles 4%, pedestrian 27%, and other types of vehicles, modes of transport 31%. So if we look at the road fatalities per 100,000, we see that the African continent has the highest number, 19 fatalities per 100,000. The Southeast Asian, and I hope you can see my cursor, the Southeast Asian region has 16, where on average indicated down here. Globally, we find 14 fatalities per 100,000. These 19, where does that come from? Well, Africa still is the continent with the highest fatality rate, and it's one of the regions where fatalities over the last decade increased instead of decreased, while the aim was to halve fatalities globally with 50%, and globally we managed by 5%. In, as I said, the African region, the increase was 17%. And of the 66 countries that saw an increase, 28 are in Africa. So clearly the African continent is not going in the right direction and needs attention. To make those numbers that were not very visible a little bit better to see, here the same information again, where you see globally four-wheelers have the highest number. In the Southeast Asian context, it's two and three-wheelers, and in the African context, it's pedestrians. Yes, the number of other is bigger, but here it's partially also bad data and not allocating fatalities to the other categories. So I would say pedestrians still hold the highest burden. Partially that is because it's the most important mode of transport. In South Africa, over 50% of trips are walking trips, and we see UNEP has even found areas where 78% of people in Africa walk. If I look at South Africa, so this is South African data, we can see that over the last 2 decades, walking has also become more important. So between males and females, in the period between 2003 and 2020, you see that for every single group that we've analyzed, the walking mode and the travel time walking has increased. This is data from UNEP published in 2022. And here you see that walking is a tremendously important mode of transport in the African context, where globally walking per day is around 40 minutes. On the African continent, the average is almost hitting 60 minutes. For the information, and given that you are in India, males and females, from the data that I've been able to find, walk less than 30 minutes a day in total. 2 and 3-wheelers are also becoming more important in Africa, and we see already in Southeast Asia that they very important, and in the when you're on the streets in India, you can see that 2 and 3-wheelers are incredibly important. Over the last decade, the number of 2 and 3-wheelers on the continent has doubled, and fatalities have also doubled. So we clearly have not identified good ways of keeping these travelers safe. I would like to just give a little bit of background on the safe systems approach. And if we're talking about safe systems, Hudson in 2007 started to analyze what a safe culture actually means. And we start off with a pathological, who cares, as long as I'm not caught, I do whatever I want type of attitude, to then looking at data and being reactive. More mature countries approaches from a calculative approach where hazards are managed, and even more mature countries will have a safety approach where they are proactive. Safety is leadership, values are driven by improvements. And the new generative AI-based approach may be that safety now becomes a naturally thing that we do and where we helped with technology, but we're not that far yet. So the countries that are doing well worldwide are at this moment in time proactive. If we're looking at being proactive and the safe systems approach, then we see the World Health Organization and the United Nations have these 5 pillars that you see on the left-hand side listed. Safe users that are educated, compliant, but physically vulnerable, and they do make errors. They also have a pillar called multimodal transport and land use. Another pillar looking at roads and road environments. Then there are vehicles and vehicle speeds. And last but not least, a pillar on post-crash care and medical care. Now in 2004, working with these 5 pillars, we found that putting them in a circle, the wheel of safety we're calling it, improves the way that we can work with it, and also identify that certain measures do touch different parts of these 5 pillars. So that you can see on the right hand side, and I will come back to how we use this in practice. In the safe systems approach, it has been accepted that we need to look at multiple facets when we try to address safety in a holistic manner. We need to make sure that engineering is taken care of, and that is road infrastructure, the vehicles, and other engineering. There needs to be enforcement, and of course that needs to be enforcement without corruption and other illnesses that we can think of in enforcement. We need to educate in schools, having good education for driver licenses, as well as doing campaigns. And we need to evaluate. We need to make sure that engineering, enforcement, and education is evidence-based and based on safety performance indicators. Thinking about the 5 pillars, maybe we need to put this evaluation, engineering, enforcement, and education in this manner so that the evaluation can inform the engineering, enforcement, education, as well as post-crash care. And this is obviously an iterative process where once you have identified on evidence-based evaluation, engineering, enforcement, education, or post-crash care interventions, you will then have to measure and monitor that ongoing and fine-tune it as you go along. Let's talk about some of that evidence and how do we look at that evidence? And this comes directly back to the different lenses in my title. We can look at fatalities and injuries in absolute numbers. This is from the World Health Organization. You see which type of countries from high to low income see fatalities and in what regions we should start addressing these. And we can see in the European regions, lots has happened already and it has been fruitful. The European region has the smallest amount of fatalities in absolute term. The Southeast Asian region, where you are, has the highest number, higher than the Western Pacific region and also higher in absolute terms as the African region. Fatalities per mode in absolute numbers could also be depicted in this way. And here we're even adding the modes of transport. So this is Cape Town, a map of Cape Town with different traffic analysis zones. And you can see here, the bigger the circle is, the wheel is, the more fatalities happen in that area. You see, for example, big circles in Khayelitsha, in Blue Downs, in Mitchell's Plain, as well as in central Cape Town. And you can see from the colors as well that also in Cape Town, often 50%, but sometimes even more than 3/4 of fatalities in a region are pedestrians. So in absolute terms, this is what we can learn from the numbers analyzed in Cape Town. We could also look at absolute numbers in this manner, where we have the overall total, for example, for Cape Town, or in this case for the Western Cape. And here you can see that there are two different sources of data, and you can also see the trend line for that data. So trend lines looking at absolute numbers over time. Why do we have two different sources? The IPAS data comes directly from the police. And although the police would like to monitor what is happening with people that got injured on the road, and although South Africa has, for example, bought into the definition of the World Health Organization, where we try to report on fatalities within 30 days of a crash occurring, the police doesn't have the manpower to actually follow up. So the blue diamonds is data that will be a maximum of 24 hours after the crash. Of course, in the mortuary, they can more accurately look at what happened, although they might also have some missing data in there. So that's where the difference in data comes from. We can also look at fatalities per 100,000. And in the beginning, we did that already. We looked at the African region and we looked at Southeast Asia and the rest of the world. You have seen this picture. So this is fatalities per 100,000 population. Here, fatalities, and this is a little bit older data, also fatalities per 100,000 for all the African countries. And this was 2010 data. So the global average was here, and only a few African countries were better than the global average. And at that state, the regional average was 24 fatalities per 100,000. It has come down per 100,000. So this is another way of looking at it. Staying with absolute numbers and per 100,000, I have put those in an overview where they're compared to each other. And this is for the Western Cape. You see Khayelitsha again, that zone that we saw in the picture of Cape Town, and some of these are also in Cape Town, for example, Nyanga, Philippi, Maitland. Now, if we look at this data, what do we see here? Well, interestingly enough, in absolute terms, I should start focusing on Khayelitsha. We have the highest number of fatalities per annum, and this was an average over 5 years. And but interestingly enough, if you look at where the diamond sits, at that stage, Khayelitsha was actually as good as the global average and better than the African average. If we look per 100,000, then Leeugamka is a tremendously high. People might think, how can we have fatality rates of 500 per 100,000? This is a freeway where a lot of crashes do happen, also with our informal public transport, long distance public transport. If I say a freeway, we know that it's high speeds. So many people become a fatality. And there is this little town called Leeugamka, and the police station of this 2,500 people town or village needs to deal with all the fatalities, hence this very high number per 100,000. And if we look per 100,000, that's where we should start. So I think it starts to be become clear why we need to apply different lenses to actually identify where to start our efforts. Here is another comparison, fatalities per mode use. So if fatalities, let's say pedestrian fatalities, are very high in an area, do we then have to look at it, or should we look at areas where fatalities for pedestrians are high and the mode use is also high, or the mode use is low? So this gives an indication that in these areas for this specific mode, fatalities are higher than the percentage mode use that we are seeing. Again, a different way, a different lens to look at fatality rates. Of course, we can look at hotspots as well. For hotspots, these dots in a specific geocoded area need exactly that. They need geocoding. So to be able to do hotspot analysis, you need to have good geographical information. And this is a study where we looked at, can people in the Western Cape, this is a map of the Western Cape, you have seen this pinkish area already, that is Cape Town. And this was, Cape Town was excluded from this specific analysis. Here was the question, in rural areas, are people that have a crash on the road able to get to emergency care? And only in the green areas that you see here, you can get to emergency facilities within the so-called golden hour, 1 hour after a fatality has happened. A new system that we are developing is looking through, looking at road safety data using a kind of an equity perspective. Road safety deserts, and this comes from the desert analysis that has started with food, is also used for transit, and it looks at, in transit, for example, where are people that are depending on public transport and how many public transport facilities are available to them. So here we look at a supply side, a safety side, and an overall desert. And here we can see in Cape Town, where are areas where, based on Z values, a statistical tool, Z values that are calculated, is the risk of fatalities for a certain mode, this can be done per mode, higher than in other areas. And I would say 10 is Khayelitsha again. You see Khayelitsha and Blue Downs have these higher risks if we calculate Z values as well. You saw those areas before. I'm not going to go through all the mathematics of this calculation. There are also papers available that explain everything. But for people that want to have a look at this presentation again, or that are getting a PDF of this presentation, this is the mathematics so far developed. As I said, road safety deserts, it's still under development. Currently, this is mathematically how far we are, and we're trying to fine tune for smaller areas, better indicators, etc. But you can see that, as always, there is a demand and a supply that's typical to this desert theory. And we have broad safety indicators per infrastructure type into it. The Z value calculation, this is a standard statistical calculation, and then how the final score is calculated in this desert approach. Let's go to evidence. Now we have done the analysis. We have, and I'm not going to look at specific analysis of how to identify that. The hour that we're having today would not be long enough. But based on this data that we have looked at, we are slowly going to go in the direction of what interventions to implement. And then interventions can be, remember, engineering, enforcement, education, and maybe post-crash care. Well, let's focus on education. Do we need to, in, for example, campaigns or the way we approach other educational approaches, do we need to bring gender into it? Well, that might depend on which country you are in, which location you are in, and based on the World Health Organization, these are all the countries that data is available for. Generally, the rule of thumb is that 20% of, and this is your 20% line, of fatalities is female. There's a bigger risk for males generally to become fatalities for all kinds of reasons. But interestingly enough, after I did that, there's also countries where many more females become a fatality. So again, these countries should look more into what are the reasons, how come, and what does that mean then, for example, for an educational campaign. Vulnerable road users, and they are, in this picture we have pedestrians, cyclists, and two-wheelers. So who becomes a vulnerability, and how many percent of our fatalities are vulnerable road users? So again, another way of looking at it. I get a lot of questions from people about helmet wearing. And, you know, if you work in road safety, logically, you would say that if you protect your head better, then, you know, if you have a crash, then you should be protected better and your survival chances should be better. There are always discussions. Does that hold for motorcycles? Does it also hold for bicycles, etc.? Well, here you see data of the drivers of vehicles and how many percent in the different countries did have do wear a helmet. And you can of course see that helmet wearing, you have countries where, you know, everybody wears the helmet. You have countries where that is not the case. But here you can see that if it's not the case, you clearly have a higher road fatality risk per 100,000 than if you were wearing your helmet. So again, an indication that helmet wearing is an intervention that you should be implementing. Same with seatbelt wearing. Discussions are there, people feel restricted, etc. But the data doesn't lie. We want evidence-based interventions, and the data doesn't lie. What we also see, and this is data for the different areas in the Western Cape when we were doing those analysis in 2018, how much data was missing, blank or unknown. This is vehicle type. So in some areas, the vehicle type was not known. Almost none of the vehicle types were known, where in other in the Berg River, for example, almost all were known. And on average, for the Western Cape, almost 50% of the vehicle types were unknown or were left blank. If we look at interventions, we now know where fatalities and crashes and fatalities have happened. We have used our different lenses to come up with places where intervention should happen. And then the next question is now, from these interventions, from maybe the deserts, and where we, from an equity point of view, should start putting interventions in place, where now what do we implement first, and what is the most cost-effective intervention, even for the same place. So I'll give a few recent examples where we and this is an approach that I will explain first, where we do purely an economic evaluation purely for road safety. So this doesn't bring into account that there might be an effect on congestion or travel time or pollution or anything else that might be positive or negative. This is purely from a road safety point of view. We look at the expected cost, and we have worked with practitioners and an institution in Cape Town called Young Urbanists to calculate costs of planned interventions. We also do an uncertainty calculation, and then we look at both capital and operational maintenance that is required for these planned intervention over a period of 20 years. We know from the literature, and we have done extensive literature reviews, and we carry on updating that there is an expected benefit when you, for example, put a speed hump in, or you provide a mirror somewhere, put a curb in, rumble strips, etc. We have a long list. This is just a short indication of the range of low cost interventions that we look at. For these interventions, you also need to think about what is how quickly will the benefits materialize. So a speed hump is generally put in place for speed reduction. And once it is built, there is an instant benefit because the speed is reduced instantly. If we look at rumble strips, then that speed reduction might not happen instantly. There is a little bit of a delay, so you get a curve as indicated in this picture. And for each of and this is just an indication, for each of the interventions that we look at, we have established these type of profiles on when, how quickly benefits will be measured. As indicated, we look at the cost and benefits for a 20-year horizon for fatalities and or injuries. We look at a crash growth rate. You have seen that in Africa, naturally, there is still an increase of fatalities. So we're going to assume that we compare with no interventions and then implementing this intervention. And as I said, we have profiles for every intervention that we have identified. We also have, and I'm really glad that I didn't have to do this work myself. It's always a tenuous topic. What is the value of a life? What is the value of somebody that perishes on the road? So in 2026, and there are inflation corrections on these numbers, the value of a life was 3.9 million rand. I haven't converted that into your currency in rupiah, but 9.3 million rand. If you purely look at the debt, and if you include the fact that there is delays on the road, that there is costs in the hospital, etc., the total value becomes 5.4 million rand. So we use this every fatality, and then you see the injury values as well. Every fatality and every injury that we can avoid will get a monetary calc value of this. Let's give you some examples. This is in Cape Town, one of the areas where we identify it's not with the highest fatality rate or injury rate or crash rate. It's an area where there is quite a high crash rate and where we think that we can identify some low-cost interventions that we can negotiate with the municipality. So here, this speed hump, it's quite a smooth one, and what is not in the picture established already, a mirror on this light pole, was the intervention that we identified for this area. And then with the information that we are having, we can calculate what the capital investment is and the annual operational costs. We have a conservative and an optimistic scenario, and for the benefits that talks about the ranges that we saw for these different aspects, in this case a speed hump and a mirror that we want to implement. You can see after 1 year, 3 years and 20 years what the benefit is, and let's stay conservative at this moment in time. The economic ratio, so the overall benefit for implementing this 45,000 Rand intervention that needs about 2,000 Rand per annum to be maintained properly, is 361, which means that for every Rand we invest, we've over 20 years get about 361 Rand back. The break-even point for overall cost is within 3 months. So within 3 months, the avoided crashes, injuries, and fatalities, and there are no fatalities, so fatalities in this specific intervention doesn't come into play, is 3 months. Here is another area. You can see quite a wide road when there is, this was taken on a Sunday, when there is more traffic, it can be quite busy here, and there are shops on this side, people go across the road. So this is another area that was identified having quite a few crashes on a road where you maybe wouldn't expect it, but and where we think we can put in low-cost interventions. And here we restricting the right turn, so there is a little bit of paint and through a curb, etc. Again, costs are fairly low, and the overall conservative expectation is that that for every Rand invested, after 20 years, you have made 550 Rand back. This is a rural Western Cape part. This was one of the rural roads where you see high speeds and quite an intense curve. And you can see that, you know, just picture yourself driving here at night. Quite a lot of crashes do happen here, also single vehicle crashes. And here we restrict, we add curbs and we have restrictions. No, this is the wrong data. This is the wrong, sorry, this is the wrong. We wanted to put more of these chevrets in, etc. And unfortunately, I made a mistake. I have put the wrong data in here, so I can't tell you what the benefits are. But again, very low in implementation costs and high benefits, especially over 20 years. The last example that I want to share with you is a school. We have done in one of our projects called Transafe an analysis of various school areas. This was one of the schools. This is in a low-cost area. You can see high density, high densities, and very straight, unobstructed road. So improving these speed humps and some other interventions and improving crossing was one of the things that we wanted to do. Here the costs are a little bit higher, 5 million Rand, and to save the children, you know, again, after 3 months we break even. After 1 year you see already more than 1 Rand per Rand that you have invested, and after 20 years you have made in a conservative calculation 100 Rand back for for every rand in that 5 million rand. We have identified, and this is preliminary work, we're still busy with this. We're sitting at the moment, this is the first 15, but we're sitting at the moment at around 29 different low-cost interventions that we are calculating through. And that we then also, and now I'm coming back to this reinvented, reimagined tool, a safe systems approach wheel that we are looking at. To put the wheel in a circle or translate a safe systems approach into a circle gives us the opportunity for each of the traffic calming measures, driver interventions, golden hour, and I spoke a little bit about that, to identify, you know, what is included. Is it for the golden hour study that we did only post-crash care? Or you can see here that for all these school zones, etc., that the user and some of the other pillars are all important. For the first 15, just as a summary, here an overview of what is a touch. So over 15, 17 or 18 of the 15 of the interventions that we had at the time looked at users, multimodal, not so much, road and roadsides, of course, many. We can, as engineers, think of many. We can think of many vehicle and speed possibilities, and also post-crash care. We had about 8 different post-crash care interventions that we had identified. I want to conclude my talk with the following. On the African continent, I think also in Southeast Asia, we can conclude that road fatalities and injuries remain stubbornly high. There's a need for evidence-based application of the safe systems approach. Road safety interventions should be identified through the analysis, using different lenses. These interventions can be engineering, education, enforcement, or based on post-crash care. As there are still queries around speed reduction, helmets and seat belts, we can confirm that these do reduce road fatalities and injuries. The identification of infrastructure interventions need geocoded information. You cannot start identifying what to do on the road if you do not know where the crash has happened. And unfortunately, I have to say that the quality of geocoding in the South African context over the last 10 years has decreased, not increased. We have many technologies, things like speed over distance, for example, that can be used and implemented and that can help reduce fatalities and fall within the safe systems approach. And my conclusion would be that road fatalities and injuries, every one of them is one too many. Thank you for your attention. And this is me and my email address. Back to you.
Thank you, madam. That was an enlightening talk. Now the forum is open for discussion. Any question or queries you can ask.
Hello, ma'am. That was a good presentation. This is Anish from NATPAC. What I would like to understand is that once you do these studies, how difficult is it to convince the authorities or to introduce these things on the ground? Because for studies, we don't require much of a implementation as such. But then, even if they are low cost, who takes up the responsibilities, and are they implemented as given, or is there any discussion that goes on and then will have to convince them so as to do these implementations?
Yeah, that is exactly where we have been battling as well. So the TransSafe study that I spoke about was a 5-year study. It's coming to an end now. I must admit that the first year I wasn't involved myself. So most of the information that you've seen that is related to that was for the past, let's say, 4 years. And we only now starting to get the municipality on board doing interventions. It also depends on what type of intervention. So if you, for example, the school that are displayed, that school we have now convinced the municipality to work with us and do the intervention. We are finalizing drawings at the moment and still hope that by August our intervention is implemented. Another intervention that we found was the introduction of so-called rescue sheets, where the technology that is in the vehicle is displayed on 1A4. And when our fire chief, for example, heard about that, within 2 weeks, he set up a meeting with us and was very interested. He indicated that they have, for first responders, a special tool, a handheld device that they use, and he would love to have all the rescue sheets that I can get my hands on in that tool. So we're working with them. So there it was, for example, very, very quick because he saw the benefits, and given that he is in charge, he can share that. Now it's on us to get all the information for him, and again, hopefully before the end of August, when our project finishes, but we will carry on working with the fire chief as well. We can get the first details in there. And just to add to that story, what we are doing is identifying electric vehicle rescue sheets, because generally the first responders know traditional vehicles, but electric vehicles do function different, have different risks if there is a crash, and hence we are focusing on that. Maybe also something that India could think about.
Thank you, ma'am. And one more question from my side. Uh, you're mentioning about the road humps or the speed breakers. So, is there any condition or a criteria that these are the roads that you can provide the speed breakers? Because in Indian conditions, we're not allowed to do that on a highway because that could lead to accidents themselves. So,
No,
do we
absolutely.
have?
Yeah, absolutely. Speed humps is only, as I said, I was looking at low cost interventions. So I was on tertiary road network,
Okay.
roads where the speeds should be low, but on high-speed roads, not even only freeways, also other mobility corridors where you find high speeds, speed humps is not the way to go. In any case, and for me, it's unfortunate that Africa still is so hooked onto speed humps, because when I studied in Europe, there was already a thinking that speed humps is maybe not the best way of reducing speed. It has effects on noise. It has an effect on actually pollution. Yes, of course, it reduces the speed, but a chicane has less other negative impacts, and still the speed improvement that we need.
Thank you, ma'am.
You're welcome.
Any other questions? Okay, thank you, ma'am. And I would like to invite Dr. Remisha TV, scientist NATPAC, to deliver the vote of thanks.
Good evening, all. We have been privileged to gain deep insight into the topic assessing road safety through different lenses from raids to desert, delivered by our distinguished speaker, Dr. Marianne Vanderschuren. Your expertise has not only enhanced our understanding of road safety challenges, but has also inspired us to appreciate the importance of data-driven analysis and innovative framework such as the concept of road safety deserts in identifying high-risk areas and guiding evidence-based transportation planning. We truly appreciate the time and effort you invested in preparing and delivering such an engaging and thought-provoking talk. The inclusion of case studies and interactive discussions enrich our learning experience and provided us with valuable insights in creating safer and more equitable transport systems. We would also like to extend our sincere thanks to all the attendees for your active participation, and we are very much thankful to our director, Professor Dr. Ashalada Madam, for her constant guidance and support in shaping this wonderful event. Once again, I would like to express our sincere thanks to Dr. Marianne Vanderschuren, the NATPAC team, and all of you for making this technical talk a great success. We look forward to much more enlightening sessions in the future. Thank you and have a wonderful day.
Thank you.